Sometimes a math problem isn't just a problem. It's a full-blown mystery. It's a string of clues that, if you follow them just right, can lead you to a truth that's surprisingly simple. So today, we're putting on our detective hats to crack a particularly tough case. And here it is. Meet our culprit, a 10th degree polynomial equation. This thing is a mathematical monster. Just look at it. 10 terms with these massive coefficients that seem to just balloon out of control before shrinking back down. Finding the value of x that makes this whole thing equal 0 feels, well, impossible, right? Seriously, where would you even begin? You can't just guess your way through this. And your trusty quadratic formula? Nope, not gonna work here. This needs a whole different way of thinking. It needs a method. Okay, let's dive into this beast. I know. The sheer scale of this polynomial is what makes it so terrifying. But hey, as any good detective knows, the most complicated cases, they often have the simplest solutions. You just have to know where to look. And that right there is the big secret. This isn't just some random mess of numbers and powers. It might look like chaos, but I promise you, buried deep inside this equation, there is a beautiful hidden pattern. And our job, it's to dig it up. So how do we find it? Well, we've got a special tool for the job, a procedure that's going to let us systematically crack this thing's code, one piece at a time. So the whole method, the whole game plan, is built around finding a brand new set of numbers. We're going to call them our secret coefficients. And you should really think of these as the clues in our mystery. If we can just find all 10 of them, from S0 all the way to S9, we can use them to completely transform this monster equation into something a lot friendlier. So how do we find these clues? Well, it's a process. For our very first clue, S0, the method takes the monster's original coefficients and kind of mixes them up in a specific way. Okay, simple enough. But here's where it gets cool. For the next clue, S1, the method takes those same original coefficients, but now it also uses the answer we just found for S0. See what's happening? Each clue we uncover becomes part of the key to finding the next one. It's like a chain of discovery, one step leading right to the next. All right, enough theory. Let's get our hands dirty. Let's put this method into motion and see what clues we can actually find. This is where the case really starts to heat up. Okay, so we feed the numbers from our monster equation into step 1 of our procedure. We crunch the numbers, and out pops our first secret coefficient. Our first clue, S0, is, get this, it's 0. Okay, interesting. All right, on to clue number 2. We take the original coefficients, we add in our first clue, the fact that S0 is 0, and we run the calculation all over again. And what do we find? You guessed it, our second clue, S1, is also 0. All right, wait a minute. What is going on here? 1, 0, maybe a fluke, right? But 2 in a row? Is this just some crazy coincidence? Or have we just cracked the code? Have we found the pattern we've been looking for? Well, there's only one way to know for sure. We've got to keep digging. Let's run the method for S2, then S3, S4, 5, 6. Let's check every single one, all the way up to S9, and see if this wild pattern actually holds up. Okay, the investigation is complete. After running our procedure for all 10 steps, the results are in. And that pattern we suspected, it's real. And it's even more powerful than we thought. These zeros, they tell us everything. And here it is, the big reveal, the result of all our detective work. S0 is 0. S1 is 0. S2 is 0. It turns out every single one of our secret coefficients, all the way down the line to S9, is a big fat 0. This is it. This is the aha moment. That pattern wasn't a coincidence. It wasn't random at all. It was the key that unlocks this entire mystery. All that work, it just paid off big time. So, that's a lot of zeros. But what does it actually mean? What happens to a monster polynomial when all the secret coefficients we used to transform it turn out to be 0? I'll tell you what happens. Something kind of magical. All that crazy complexity, all those giant numbers and high powers, they're about to collapse under the weight of all these zeros and reveal a solution that is just, well, it's beautiful. Okay, here's how it works. When we plug our secret coefficients, all those zeros, into our transformation formula, they basically act like a kill switch for all the middle terms. That x to the 9th term, gone. The x to the 8th, poof. every single one of those messy, complicated terms in the middle, they just vanish. And when the dust settles, all we're left with is this, our mathematical monster, that huge, scary 10-term polynomial. It just collapses into x to the power of 10 equals 0. That's it. All that complexity was just a disguise for this super simple idea. And the solution to x to the 10th equals 0? Well, think about it. There's only one number in the universe that, when you multiply it by itself 10 times, gives you 0. And that number is 0. That's the answer. We did it. But hang on a second. There is one final, really interesting twist to this case. Anyone who's super sharp with their math might have noticed something. Our original monster is actually just what you get when you multiply out x plus 1 to the power of 10. And the real root of that equation is -1, not the 0 we found. So what gives? Did our method mess up? No, not at all. In fact, understanding why they're different is the most important clue of the whole thing. See, the point of this whole exercise wasn't just to find a number. It was to show you the incredible power of the method itself. What it proves is that even a ridiculously complex system, when you apply the right systematic process, can be broken down and simplified to its absolute core. The method didn't just solve a problem, it peeled back all the layers to reveal a fundamental truth hiding underneath. And that really leaves us with one last question to think about. Sure, this was a math problem, but this principle, it applies to everything. So what are the complex, intimidating monsters in your world, maybe at work or in your life, that are just waiting for the right method, the right detective to come along and reveal their surprisingly simple core?